This is part 3 in Cadence tutorial. So previous part was about how to make schematics, all the shortcuts and etc. for it. One thing I missed was buses. I'll cover that. I'll cover hierarchy, which is really important when you're making a large design. And the most important part, transferring designs. So you're doing some design on your account. How do you transfer it to someone correctly? It's not as simple as just copying the library. There are, and how do you check whether everything inside is correct? How do you make sure all the files, all the schematics exist in the same library? They're not scattered across different libraries. So first of all, bus says, let's say you have something like this. You have 5 inverters. There's one more way of making this. Is you take this, whatever your VDD ground is, now instead of just having, or instead of just writing the name in there and out here, you can do this. So in net, let's just start with 2 inverters in a line. So there's net 1 going here, and then there's net 1 out here. So this means that, and add this more, one more thing, 2:1. So it means that there are 2 inverters present here at this location, and the first one, the second one, denoted by I52, has the connections in at the input and net 1 at the output. The second inverter, inverter 1 here, would get net 1 as its input and out as its output. So if we expand it, it becomes that input going through this inverter becomes net 1. Net 1 again goes to another inverter, a different inverter, comes out as out. So just for 2, it doesn't matter too much, because like it doesn't take too much space. But you can do something like 31:0. You have a 32 inverter chain, and even the nets, right? There's net 1 here. You can just say net 1, it should be 32:0. Let's see if that makes sense. 32. Okay, so the 31st inverter will get input and give away net 1 30, and then net 1 30 goes to the second, and it continues till net 1 0. There's 32 nets as inputs here, and then that gives you out. So there are 32 inverters in series here. You can do the exact same thing with your devices, so your MOSFETs and all this. You can do this exact same thing, not an issue. And this will, it may make things a bit confusing to look at if you're not really familiar with this syntax, but it can make your schematics cleaner, and depending on your use case, this might be a better method to represent things. So this is what buses are. And now if I just like try to save it, there's 4 warnings here. So input is floating, true. Okay, it might be getting confused because there's capital N, small n. Okay, yeah. So all of these nets, they're connected somewhere. So that's why we are not getting that no con error here, no con warning here. So this is about buses. But you have to be really careful when you're using buses like this, multiple instances of your design like this, that you have to be sure what's happening to each port. So ground, there's just one net called ground connected here. So, but if you see here at the bottom left, check here. It says instance pin I5 31 is to 0 ground, that's the pin that has the net ground, and there are 32 instances of ground present there. Same thing for your VDD. So it's something to keep note of. In case I just don't keep this, I say something like net 2 here. What it means that is all 32 of these inverters, all of them have the same output. Here it doesn't matter, it's like keeping 32 in parallel, which you may want to do. This you should never do, and or you should be really careful when you're dealing with current mirror or something, because that's when you'll have these kinds of constructions where there are multiple NMOSs, multiple PMOSs, nets are coming out of it. All of them should have independent names. If they have the same name, that should be by design, or you should not give them the same name because it can become more confusing. You just simply give them separate names, or keep a bigger multiplier, bigger width, all this. Otherwise, all of those nets will be shorted and your current mirror may not work as expected. Another thing here is, which Cadence will probably stop you. Let's say the width is not correct. Here there's 31 nets, but there are 32 inverters, so it doesn't fit here. If I try to save it, check and save, so Shift X, it says there's an error. So it won't allow me to save it. It is still like, it still allow me to save it, but it's not really recommended. So error, this width 32 bits does not match the net, which is 31 bits. So never keep these kinds of errors in your design. So I think that about covers the buses. Now there's the point about hierarchy. So as you can see here, there's just a single inverter here. At the output, there's a cap. If we go inside it, see what this guy is made up of. How I'm doing this is just double click on this, and it shows you this option, descend into the schematic, or you can descend even into the symbol. So I want to descend into the schematic. I want to open it as read and all this I'll explain in this video just later. What does it mean if it's open for reading, if it's open for editing, locks, etc. So as you can see, there's this inverter called inverter level 1. Inside it, there's inverter level 2. If you still go inside it, there's 2 inverters, level 3 inverters. If I go inside this, there's 3 level 4 inverters. So I don't think this is too complicated, just that this level 1, each one of them, there's just one here, but each contains one level 2 inverter. Each level 2 contains 2 level 3 inverters. So by proxy you can say that there are 2 level 3 inverters in even level 1, but each level 3 inverter contains 3 level 4 inverters. So there's 3 times 2, so that's 6 level 4 inverters at the top level. It's not very complicated, it's just that there are 3 inverters inside the 3 inverters inside this. So there's 6 inverters in total, right? So this is what hierarchy means, is that there are smaller blocks inside your bigger blocks, and you can denote them with symbols and save the space required and save the design effort by reusing things. And by the end of it, you can just have your transistors. But in total, there's 7 factorial inverters present in this, because there's 7 here, 6 here, 5, 4, 3, 2. So there's 7 factorial inverters here. It's easy to depict them here, even though it's a huge number. One more thing I was using this shortcut is you can press Control Tab to move to the next tabs here, and Control Shift Tab to move back into the tabs. But if you go into Maestro, then you can't come back. There's some weird quirk of Virtuoso that you can enter it, but you can't exit it through the keyboard. So that's hierarchy. One thing which I want to show here is the validity of these designs. So right now I have this simulation set up here. I can just try to run it. Okay, yeah. So this is what I wanted to demonstrate here. You have a design and it seems like everything is fine here. So what's the issue? So if you check in the Cadence terminal, it says netlist generation failed because error. Yeah, inverter level 5 has been modified since the last extraction. Check that the schematic is correct and run, check and save. So level 5, we are at level 5. Yeah. So here we were messing around with that buses thing. What it says is this is not a valid schematic because it has not been checked and saved. How you can do a check and save? Right now you can't, because this is open in reading mode. You can't edit it. Even if I press Q or something, all of it is blanked out. You can't edit it. You can't even move any of this. You can copy it, you can't move it, right? So how do you solve it? Select file and make editable. File, make editable, and you just press this check and save. So in case you tried to edit something, didn't save it, Cadence will not let you run simulations in that case. If any of the associated schematics of your simulation, you open them, tried to edit them, didn't save them, because it's not sure which version it should use, whether it should use the previously saved version or the version which exists in your RAM, the currently being edited version. So that's why it will throw this error that it's not has been modified since the last extraction, validate that the schematic is correct, and run check and save. So I did save it. I can just make this read only again to prevent any unintentional changes now. Let's try running it again and see if it works. So it's saying compose simulator input file successful. And as soon as you start seeing this window, the simulator output, you know that things are working. So that is how do you check for validity. Now this is not a really good method of checking validity. To try to run it, see what error it throws, and then going inside and solving it, because some of your designs may have errors in them. So you have taken it from someone, maybe the like transfer wasn't correct, etc., etc. It may have errors, so you won't be able to run them. There's like 10 different schematics with errors, or even like some check and save error, some extraction error. How do you check all of them at once when you have something like this? Let's say there's something here, and just this guy's changed with some other version of our inverter, just this one instance, and it's coming from a library which has now been removed or deleted or something. How do you make sure that all of it is correct? So the method is, there's check. Again, you need to be in editing mode. Check hierarchy, and ask it to process every schematic. Check every reference library as well. Open for you can leave this auto. Save schematics. If there are errors, ask me. So okay, it will go through all the cell views, and if there are any errors, it will do check and save for all of the internal schematics. If there's any error, it will say that these n number of schematics, they had some error. Do you want to save them? Do you want to open them? What do you want to do? So just to demonstrate that, I'll create an artificial error here. Out to 2:1. So just a simple like bus width error here, and this has not been saved as well, so it should not let me run again. Yeah, there's one more type of error which you can see, is because that internal cell view is not saved, have been modified since the last extraction. Click update and run to re-extract the schematic cell views. Usually this works, you can just do update and run. Here it won't run because there's an error in the design itself. Here you can do check hierarchy, and now it will say save schematics with error. It says inverter level 6 has a error. Do you want to save it? And now at this point you can go inside and like fix it. Check and save. And to quickly convert between editing and reading mode, you can just do Alt Fm. Alt Fm. So Alt code is just Alt, and there's a file. There's a F is like underlined. So you press Alt F, it opens this window. And again inside this, make read only has M underscore. So you can just press Alt F, then M. You can do this for all the other commands as well. Even in Calibre and all this, to quickly open DRC, quickly open LVS, you can use these shortcuts. Okay. So that's hierarchy also covered. Checking validity. Okay. Locks. Locks is one more thing here. Again, let's go with this. I'll just make some change here. And right now it's like you're seeing the start, so it's like open for editing. Let's try to see this thing. You can see there's a lock thing here, right? It is logged by my account at this server, and it's saying this for like all of these guys. Level 9 and level 10 it's not showing because they're not open here, but yeah, this is locked. What this lock means is, I'll show that as well. So there's like level 6 schematic. So this thing, schematic OL CDS lock and schematic OL CDS lock by this server. So what's happening is, let's say I'm working on this schematic, I'm trying to edit it, design it, whatever. This library can be accessible to other people as well, working on the project, etc. How do you prevent multiple people from making changes at once? Because I may be making some changes here. Someone who opens it right now will see the saved version, not this version with the additional inverter here. Because this additional inverter is added right now in the RAM of this server, not in the storage, right? So how do you prevent it? You put locks. So the other person can just see the schematic as it's saved previously. They won't be able to edit it, and there's something called a refresh as well, which I'll come to. So that's the whole point of locks. Very similar to how there are locks for Cadence itself. This was explained in, I think, part 1. So that's why there's a lock here. While there's a lock, uh, if you transfer this file to some other computer, etc., you can't normally remove these locks. How do you normally remove these locks? By just doing okay, yeah, I'll just delete this. It is still locked because like I've made some changes. I'll save this, change this to reading, and I'll just like uh, let's see if it updates. So yeah, level 6 it is saying there's no lock, right? Level 3, level 4 it is still saying that there are locks present here. Okay, there's still a lock on level 5. Yeah, this is open in editing, that's why. If I change this to reading, now let's see if the lock is present or not. Yeah, level 5 the lock is gone. So it's as simple as that. If it's open for editing, it will have that lock. If you close it, for editing, if you open it for reading, then the lock will be gone. At least that's how it's supposed to work. Ideally, what can happen is you're working on this and your server crashes. The power goes out, something. What will happen then? Because the last thing that Cadence remembers is this thing was open for editing and nothing else happened after that. The system just went down. So this lock will still be present. And how things are organized, you may or may not be able to remove this lock from this computer. Especially if you like this server crashes and you try to open it from another server, that server will never be able to open it for editing ever again, because this lock cannot be removed by some other computer theoretically, as it's supposed to work, right? So how do you fix this thing? How do you remove the locks? One really bad method people use is to delete these two files. It works, but if you have like some huge design, you can't go into each schematic, delete this. Maybe the symbols are also in open in editing. How do you remove all of them? All of this. A lot of drama is associated with it. So a better method is wherever you opened your cadence, right? Where you did that /virtuoso.run, you run this command, cls admin tool. So this, if you just do help here, so you can list all edit logs in some directory. You can list all edit logs by some specific process. So this specific cadence which I've started on this server at this specific time, I can just check the edit logs created by this guy, by this cadence, and all this, and I can release them as well. So ARE to release all logs, ARE with the directory name and the host name and the PID and the process creation time to target some specific process ID related locks, all this. So I can just do this path, right? I'll do ALE to list all the locks, then C. So it says there are 8 edit locks present, right? There's a maestro lock as well. Maestro will also get locked. You can edit maestro in read only and run simulations, but whatever changes you make and all this won't get saved. So you can remove all of these locks by just doing a RE and the path. And I would highly recommend to never give some path like just libraries, or to give a path like desktop, or even worse, just this path, your like whole account. I've seen people just release all the locks present in your entire directory. It will crash and burn your NAS, the NAS from which all of your data is coming. You're basically asking it to go through each and every file. You're asking this CLS admin tool to go through each and every file searching for these locks. It's a If you're just targeting a small library, it's not an intensive task. Even targeting a single library, it's not a huge task. If you ask it to go through all the files present in your account, it will put a lot of load on your server, on your storage itself, which are most probably hard drives. And I've seen these ARE commands run for days on end by people who don't know what they're really doing with this command. So please try to understand what it's doing. It is going through all the files one by one, searching for the specific log files. So never ever give it more than what is really required. Where you really need to remove logs, just use it there. Otherwise, you're going to ruin the experience for everyone who is working on the server, even uh, anyone accessing data from that server. I've seen this command run for days on end. So please take care of this. You can exit this through exit, simple as that. So that's logs. One more method to remove logs, how do you, if you're like closing Cadence, I've seen this happen sometimes that you close Cadence, file, exit. Yes, if you press yes, it is supposed to remove all the logs which are present here, but it may not end up doing it in case the Cadence closes too quickly or something. I don't know. I've seen it not remove the locks perfectly sometimes. So how do you resolve that? You close data. And if what this means is, for all the modified data, you can say that if there's some schematic, you made some change there. Do you want to save the change, throw away the change, or ask you each time what to do with the change? I usually keep it on prompt because I never keep anything edited but not saved. It's not a good practice. But you can close all of this by doing this prompt all, okay, and in your Cadence terminal you'll see that all of these files are saved, and in the file manager you can see all the locks should be gone. Here the lock is not gone. Let's see if refreshing things makes any difference, or maybe it won't. Okay, so this lock didn't go away. So we can close this also. Yeah, now the lock is gone. One more thing, there's the refresh. What the refresh is for is, let's say you remove the log files using CLS admin tool or something. It may or may not appear here instantaneously. So you can ask Cadence to refresh and see if the logs are gone and all this, and see if there are new cell views in your library, there are new libraries, all this. So if you make any changes directly in the directly in the cds.lib file, if you directly make changes, if someone else has added a few more cells into this library, they won't appear unless you like refresh them here. So they may appear, but not necessarily. So you can do the refresh from here. Uh, Same thing for locks. If the locks are gone, you can check them from this. Also, not just someone adding a new cell view to an existing library, adding new cells to an existing cell. So someone created a layout. Your layout person is working on the same library, same cell. The layout is present here. They've worked on a separate account, but they're accessing the same files. So you can just do refresh and that layout should appear here. Also, going further beyond, let's say you have this, open it for read only so that you don't create a lock here. Also, one just short notice, whenever you're opening any design, especially like any critical design, always open it for read only. If required, then you can change it to edit, but for the most part you can get things done if you're like checking, doing simulations, by just simply opening it as read. So let's suppose someone else has made some changes into the schematic as well. They won't appear here unless you refresh them. So that's something. So if you're working on a huge project, multiple people are working on the same libraries, so then this will be very useful, the refresh. And the libraries, etc., they have been covered in the previous videos. Now, uh, the last like huge topic, it's transferring designs. So let's see, have this test bench, inverter chain, and you have this maestro. So you can run your simulations from maestro, right? Let's say I want to send all of this data to a friend. How do I send it? And yeah, how do I send it? One thing I can do is copy this entire library, inverter chain v1, it's there. Wherever it's kept, you can check the path here. So from that path I can just copy this entire thing and give it to them and tell them that this maestro, it opens there, you can use it. It sounds fine. There are few things you need to take care of. First, like the very obvious thing, the PDK should be the same. Even the name written for the PDK should be the same. Because when you transfer something like this, okay, you have this inverter base. Because you're just transferring this single library, inside it, there's this PMOS, and this PMOS is coming from GPDK 180. Now, if the person whom you have shared this doesn't have the exact same library, GPDK 180, with these exact same names, PMOS and NMOS, then it won't appear there. It will just appear as like a crosshair. And you can't run simulations, you can't do anything. You'll have to manually go inside and like change this, all this drama will be there. So, first of all, you can only like reliably transfer data to other people if the name of the PDK is same, among other things. Like there might be things from analog lib, there could be no con from basic, all this. So they should be maintained. This seems too obvious because of course the PDK should be same in both the accounts. There are standard cells as well. You could be using the standard inverter which is coming from some other library. It could be coming from test one or something. In that case, you have just copied inverter chain v1 and all of these things. Inside it, the data stored just says that take the inverter from test 1 by this name. The other person, if he doesn't have this library with this inverter, then again you'll face issues because there will just be a blank spot there. It will say that this device, it couldn't find it, right? So that's about your standard cells. And if you have a really huge design, it may be spread across multiple libraries. So in that case, you need to copy over all the relevant libraries. So that's like the bare essential for understanding like transferring designs. You need at least all the designs to be present and all the designs to be transferred, right? Second thing is, not coming to the maestro right now, just the schematics. uh, copying something copying something is kind of tricky in Cadence. So let's say I have this TB inverter chain. This schematic is there. I want to copy it to test 2, and I'm thinking I'll just copy this test bench to test 2 and just transfer test 2 to whoever needs it. I don't need to send this inverter chain even. What will happen? I'll show what will happen. So I'll just copy the schematic to test 2, and all these options I'll get into why they're required. Data DM, it doesn't really matter. You can overwrite it, don't copy it, doesn't matter. If there's something like you're overwriting the schematic or something, then you need to pay attention which version you want to keep. But yeah, now I just copied TB inverter chain, there's a schematic. And at this point of time, if I try to copy test 2 and like copy this library, give it to someone, it will be completely useless because this inverter is coming from inverter chain V1. The library is inverter chain V1. So you need to transfer both then, right? Inverter chain V1 and test 2. How do you solve this? Because you kind of wanted to transfer all the internal things as well, right? So I'll delete this for now. Our aim here is to transfer a design to someone else, and either you can give this, or maybe your design is spread across multiple libraries. How do you make sure that all of it is just stored in a single library and you can just share that? Or even like how do you copy it? So let's try copying again, but let's pay attention to this copy hierarchical. What this means is all the hierarchical schematics which exist in TB inverter chains schematic, they will also be copied. So all the internal connections, all the internal schematics, they will get copied. This is kind of what we want, right? So that if your design is spread across 3 4 libraries, all of those schematics will also get copied over, right? But while it's doing this, you don't want it to copy like your NMOS as well, and you don't want it to copy your PMOS as well. You don't want it to copy your basic no con. You don't want it to copy the BDC from analog lib. How do you avoid that? So you skip libraries like AHDL lib, analog lib, basic, GPDK, RF lib, substrate. These things you can skip, and there's like a good dialog box and all this to do this. Now, if anything is coming from test 1, I want it to be copied, right? So it should mean do not skip. And yeah, copy hierarchy, skip libraries, views to copy, all views. In case you have like maestro setups as well, you have layouts as well, and you don't want to send layouts, you can say like don't copy all views, just copy all the schematics, just copy all the symbols. You can do this, or you can do like these types. just like the Verilog things, just the schematic things, just the schematic symbol things. You can do that way. Otherwise, you can do all views. Let's see how this appears at the end, because still we haven't reached what we want here. So now it is throwing a few issues. It says that inverter base, there's already inverter base in test 2, which we made in the last video. There's an inverter base schematic, there's an inverter base symbol, and this will override it. Yes, we want to override it because that has a different symbol. If you don't overwrite it, it will be a mismatch. It will be a mishmash of a differently constructed inverter with this entire design. So that's why I'll just do overwrite here. No need to do overwrite for the data.dm, both of these things, but at least for the schematic and symbol, you need to do overwrite here. In other places, you may or may not need it depending on your case. So it is copying. All of the copying is done. At the end, it will say here copy succeeded, and all of this is present here. Now let's try opening this TB inverter chain. Do you imagine it to work correctly? Because it is not going to work correctly. Show you what is wrong here. So let's say now you copied test 2, you give it to someone, they still won't be able to use it because you open test 2 TB inverter chain. Inside here, this inverter is coming from inverter chain V1 again. It is still coming from that other library. So that other person doesn't have inverter chain V1. You have just given them test 2, right? So it will just appear as a box here. In case you're not clear what that, like, it just appears as a box, what that means, I'll just show that quickly. cds.lib. So let's say for the sake of argument that we don't have an inverter chain V2 and we just copied this. Now we don't need this. So I've removed this inverter chain V2. Now what will happen? Again, I've changed the cds.lib, so I need to do a refresh. Update lib list. These were marked for deletion. Okay. So in case you remove some library and like you were working on that library for something, your Cadence will have some trouble dealing with it. So you ask it to refresh, it will say like you need to close all these things and then refresh. So close data. You can just selectively close these things, the things coming from inverter chain V1. But just for this, I'll just close everything else except this test 2. Now that it's closed, let's try refreshing it. Okay, something else is still open. I just close everything then. Close, refresh. Okay, yeah. Now let's try opening this. Yeah, so this is what will happen. You transfer this test 2 to someone, they'll see this error each time they open it, or each time they open any internal schematic as well. Is that the following masters are used in the cell view, following designs are used, right? The masters here means the designs, the symbols, but cannot be found in your search path. It says that there's no library called inverter chain V1, or even if you have that library, the cell may not be present, symbol may not be present, etc., etc. So this is what happens. You have this inverter V1 and this is just a blank box. You can't do anything with it. How do you resolve this? How do you end up, how can you transfer a design to someone? And just to make things clear, it's not that there the inverter level 1 is not present. You have that. There is an inverter level 1. If you remember, inverter level 1 contains inverter level 2. Inverter level 2 is also present here. All of them are present, but they are not linked. the internal references are messed up. I hope that is clear, because let's see this. This is fine. This refers to GPDK 180, it still refers to GPDK 180, and it's just fine. It's just that the references aren't correctly aligned. How do you fix it? You can't fix, you can technically fix it even now. It's a mess to fix it at this point of time. But in case you don't have any other option, you can fix it by just doing Q instead of inverter chain V2, you say inverter test 2. Because you know test 2 contains inverter level 1, right? Now it's fine. But not really. It is not fine. You go inside this. I'll open it for edit. Again, it is still searching for inverter level 2 in inverter chain V1. So again, I'll tell it, test, search for it in test 2, save this guy, go inside. There's 2 of these now, both of them. I can do all instances, change it to test 2, and you can keep doing this for the 7-8 levels which exist in the hierarchy. This will be even more of a headache if you have different cells. Here I can just do like select all masters of the same kind, select all instances of the same master. In other cases, you may not be so lucky. You may have 10 different symbols and you need to change the library name for all of them. It's a mess to resolve. And even then, you may miss something and your simulations won't work. So, how do you avoid all of this? And just to show the previous, to refresh your memory on the check hierarchy. If you try to check hierarchy, it will crash out. It will say level 3, there's error, right? Because there's error. How do you fix this? By copying the entire thing again, and we'll use a different option this time while copying. So let's refresh. I just added the library. The schematic we want to copy. Just to be safe, I'll delete all of this. I've personally found that any copying and all this is pretty wonky in Cadence. So I would recommend you to be on the safe side and like not try to overwrite a lot of things, because if all these cells already existed, it may say that they already exist, no need to change them, and it won't update the internal references the way which we're going to do it now. So let's try to copy schematic, the same options as before, but update instances. This thing now, update instances of new copies only. Now what will happen is this TB inverter chain schematic gets copied. It contains some other symbols inside it. It will say that whatever hierarchical copies are present of the internal symbols, they should be used in the copied version, in the new copies, instead of the original references from inverter chain V1. And even inside, like it will keep going inside it and update the instances of new copies, the copied versions. If you ask it to do of entire library, it will change the references for all of these guys as well, which will be a completely different level of mess to deal with. So hope you understand what will happen if I keep this of entire library. It will copy the schematic into test2, all the internal references will change to test2 in test2, but all the references for inverter level 1, inverter level 2, their internal references, these will also change to test2. This might be helpful in some places, but if you're not careful, it can ruin your hierarchy. So be really careful with this. Here we need of new copies only, so whatever exists here, that will stay as it is. The copied version, the new copies will update their instances, and now we will finally get the thing which we were trying to go for. Okay, sorry, the I didn't select test2 here. Yeah. And it says there's a schematic already present here. Overwrite it, overwrite it. You can do auto rename as well. Based on what your needs are, you may need to rename it. And if your design is huge, it may ask this multiple times as it goes through the hierarchy, and as you tell it whether to override, whether to auto rename it, what to do about its internal connections, all of this. So when you're copying something like this, never just press OK and go through it. At each and every step, verify what it's really going to do, what the copy is going to do, whether the hierarchy is going to be maintained or not. So schematic, let's see if it's finally okay or not. Yeah, so this is coming from test2, this inverter, this again is coming from test2, these two are coming from test2, these are coming from test2, right? And this is what we expected. Now if I transfer test2 to someone, they'll be able to access all of it because all of it is present, like saved inside, right? Then, but if you go to the original thing, inverter chain v1, here it's still inverter chain v1. If we had selected of entire library, this would have been changed to test2 as well. You may want it sometimes. I'm not saying it's a useless option, but it can completely destroy your hierarchy and how you've arranged your libraries. So be really careful when you're copying, especially huge hierarchies and all this. So that's the hierarchical copy, internal references. Now that you finally have test2, this is still schematic. I haven't shown how to copy Maestro, but quickly going through this, if you want to transfer your library to someone, you do this, you compress it to tar xz something something, and you transfer that zip file instead of transferring the folder or something, even downloading through MobiXDOM. Make a zip file because it can have like thousands of files inside it. Zipping it would increase your speed a lot. Now coming to the final part of this, the most difficult copy which you can do. Also, one thing to note here is it only copied till level 7, but inverter chain v1 contains inverters till level 10. Why is that? Why is it only till level 7 here? Because TB inverter chain in its entire hierarchy never contained level 8, level 9, level 10. That's why it doesn't contain that. So that's why I didn't need to copy it. And you can quickly check hierarchy using edit hierarchy, I believe. Yeah, edit hierarchy, print tree, top to bottom or like current to top, whatever, current to bottom, all this. So here it's like a very clean looking thing. So test 2 inverter base is there, 7 of them. Each of them contains your GPDK and MOS symbol. This is one of it. GPDK and MOS symbol 1. Basic IO pin symbol. There's 4 of them. And this there are 7 of these present in inverter level 7. There are 6 of these present in inverter level 6. All this. And all of them contain like 4 more IO pins, etc. That's the so you can print your tree, find out where your all of your designs are coming from, where your symbols are coming from. Another method to find out your hierarchy really easily is you create a new config. So by config, it's a hierarchy editor. Why would you want a hierarchy editor, and how can you even edit a hierarchy? These are questions which will be answered later. This is really helpful when you have a test bench or something and you want to do some like specific simulations with it. So you just use this, use the template specter, whatever your schematic is where you want to see your hierarchy, this thing. Oh, okay, sorry. We don't want inverter base, we want TB inverter chain. That's what we want to see the hierarchy for. And once you change this, if you change anything here, if you change anything here, do this, recompute the hierarchy. You can also do it from view, update. Okay. So it shows you there's what all cells are present. There's a level 7 cell, level 6 cell, all this. There's a base cell, there's a specter, NMOS, specter, PMOS. What this specter means I'll cover later. VDC, cap, VPulse, and the overall schematic. And the overall thing will have this sign as well, right? You can do things like change it to system verilog. What this means is that in your simulation it will use system verilog instead of your schematic. So as you can see, I change this to system verilog. Now in our hierarchy there are no more NMOSes or PMOSes. So yeah, it reflects whatever is contained in your design. I'll change it back to schematic, and these are back. So NMOS and PMOS from your GPDK 180. And again, you can see the tree here this way. Yeah. And you can change it to something else, etc. All of this you can do. Change this to system verilog. Okay. So now just this one block is system verilog. All of the other ones are just schematic as before. And even in this view, you can see that this is system verilog version, there's a schematic version. And PMOS and MOS also exist. This is also one way of looking at your hierarchy. This will be discussed in much more detail for mixed signal simulations. It is essential for mixed signal simulations. Now, the last topic, how do you copy a maestro? I haven't gone into too much detail about maestro. I've just shown how to run a simulation, a basic simulation. But how do you copy it? Because it's not the same as this thing, as just copying a schematic. I'll try to copy this, maestro, copy hierarchical, skip libraries, update instead of new copies, all the settings as we discussed previously, don't overwrite. Yeah. And also, in case you didn't catch it, I did end up deleting all the old things there. So now, yeah, the most incredible thing has happened and it has not copied anything. So if you open this maestro, The maestro is present in test2 library. But if you check the design, what design is it running the simulation on? It is running on inverter chain V1, TB inverter chain, schematic, but it's coming from inverter chain V1. So how do you transfer a test bench to someone? That's the question at hand, right? Let's try it again. Let's try some other method. How can we do this? Let's take, instead of just copying maestro or schematic, I'll just copy this thing. We have that option, right? You can just copy the entire cell, same settings, and copy it to test 2. Okay, now, yeah, the override thing as before. Now test 2, there's a maestro here, there's a schematic here as well, all the other internal things are present. Let's check the schematic first, is it fine or not? So schematic, inside it refers to test 2, even inside it refers to test 2, so this is fine. This is as we expect. Maestro, is it fine? And right click on the test, design, it is coming from test 2. Okay, so at this point I think it's fine. What I have observed is, if you just try to copy maestro as I showed earlier, doesn't mean that your schematic will also get copied, and then it's a huge mess trying to copy everything. But any time when you're working, you want to send database to someone, you want to send test bench to someone, make sure to open your maestro, see if the design is linked correctly. The best method would be keep another Cadence folder, you copy just test2 there, and you just keep your GPDK 180, your standard libraries, you just keep there. Don't keep any of your other libraries with your test benches and anything, and try to run the simulation. If the simulation runs as expected, then you can transfer it. Because I've seen so many weird cases happen and so many issues happen trying to transfer databases. So always, when you're transferring, make a zip file. After all of that is done, and after you make sure that there are no locks here, because what can happen is, again, yeah, one again small thing for transferring databases. This is open, you make a zip file of test2 now, the lock will still be present, and the people you're dealing with may or may not know how to remove lock files. So the best practice is, you close all data, then make a zip file, maybe go through the CLS admin and remove all locks, check if there are any log files in the database that you're sending. After doing all this drama, you get the zip file. The zip file which you're going to upload on the server, which you're going to send to them, you extract it in a different Cadence folder. Try to run the simulation with just the data that you're going to send them. If it works, if that simulation works, then you send it. Otherwise, you need to debug why the copy did not work correctly, because copy doesn't really work that well. You have to be very specific in terms of the settings which you're using, the libraries which you're skipping, all this. So I think that covers logs, check and save, hierarchical copy, internal references for your design. All of these concepts are essential when you want to transfer designs. And the thing which I missed last time, which are buses, how do you make huge designs into a small area, how do you describe them in a cleaner way, and hierarchy. So I believe everything about schematics is done. If I've missed anything, please let me know in the comments. or contact me about this. I'll make some more videos on it. I've not covered absolutely everything because I don't know absolutely everything. The next parts will start with simulations finally. Okay.